Welcome to Module 5 of AP Environmental Science. This module covers energy, the way that energy moves throughout the environment, and feedback loops of how things kind of cycle back to either keep things in balance or to drive change towards the end of a process. Now the first little bit, and I'm not going to spend much time on this, is there's some vocab terms that you kind of need to know, but you just need to know the difference between them. You don't really need to memorize the definitions of these. So energy is the ability to do work or transfer heat. Joule is kind of the amount of energy that's used, so it's a way to classify amounts of energy. And power is how quickly is that work done. Now, another term that will come up is kilowatt or kilowatt hour, and that is a way to measure a unit of power. So not a unit of energy, it's a unit of power. So just kind of understand that these terms are all just slightly different in how they relate together, and you'll be just fine. That's really the whole extent of that section. Then it gets into the difference between potential and kinetic energy. So potential energy, that's energy that's stored up. Kinetic energy is energy in motion. That should be a review from past science classes. And again, I'm not going to spend a ton of time on that. But what I do want to briefly mention is that energy plays an important role in the environment. So ecosystems where there's more energy available tend to have more life and more biodiversity. Ultimately, all of the energy on Earth comes from the sun. So places that have more sunlight, such as places near the equator, are going to have more energy available to have life processes happen than places further away from the equator, such as near the Arctic and then the tundra. So those places you're going to see less variety of life and less large life forms. So it all has to do with energy. All right, then we get into the laws of thermodynamics. Again, this should be a review of your chemistry classes. The first law of thermodynamics: energy cannot be created or destroyed. So sometimes that energy is stored, sometimes we transfer that energy from one form to another, but we're never creating energy and we're never destroying energy. The second law of thermodynamics is that when the energy is transferred, the quantity or the amount of energy stays the same, but its ability to do work decreases. Typically, if you think about the amount of food that you eat for your body to do life processes, there's energy stored in that food. And when it goes into your body, you're able to use a lot of that energy for your cells to do normal life processes, for you to be able to move around, for you to be able to talk and carry things and all that. But you also lose some of that energy as heat. So your body kind of radiates out that heat. We're able to thermoregulate. So that's that second law of thermodynamics at work. Another way to think about this is energy efficiency. So if we think about different forms of producing electricity, what ones are more energy efficient? What ones are able to use the energy best to be able to avoid that second law of thermodynamics, that the ability to work decreases. We're trying to reduce the amount of ability to do work decreasing. We're trying to make minimal decreasing. So I really like this figure here. So we have our coal plant, and as that coal plant generates electricity, 35% is transferred to the power lines. 65% is lost as heat. So it's going up that smokestack, out into the atmosphere, never really being productive. Now, as it goes down the power lines, again, you're losing a little bit of energy. So you're losing it from that friction and a little bit of heat. But I mean, for the most part, that's pretty energy efficient. 90% makes it to your home. Now that light bulb, if that is an incandescent light bulb, so the old school ones with the little filament across the top, those light bulbs heat up quite a bit, and they're going to lose 95% of their energy as heat, and only 5% is going towards the light bulb. So if we want to figure out the total energy efficiency in this scenario, let's see here. Oh, this is different light bulbs. Oh, it's up here. Never mind. We say that our cold generation is 35% efficient. Our power lines are 90% efficient, and our light bulb is 5% efficient. So of the 100% possible electricity that was generated, only 1.6% of it is actually able to be used. That's a huge amount of loss. And considering the environmental impact of burning coal to produce electricity, that's super inefficient. It doesn't make any sense to do it that way. Now, we can increase the efficiency of the light bulb. So we can use an LED. Now, an LED is a 25% efficiency. Okay, it's not great, but it's a lot better than the 5%. So that's a way to increase our energy efficiency. All right, briefly about entropy, which again, this should be a review from past science classes. Zoom out a bit, try to get rid of that glare. Entropy is the amount of disorder in a system. So think about this bedroom here. In order to restore order to that room, energy needs to be put in. So there's a lot of entropy in that room, a lot of disorder. And in order to reduce the entropy, you have to go in there, you have to use some energy, you have to do some work in order to clean it and organize it. And so energy is required to reduce the entropy. All right. Few more terms. We have different types of systems. We have what's called an open system and a closed system. If we look at the Earth as a whole, we can consider the Earth an open system if we are looking at solar radiation. So we're saying solar radiation comes into the Earth is the system, but we also lose heat out of the system, so there's outputs. If you have inputs and outputs, that means you have an open system. Stuff's coming in, stuff's going out. If you do not have any major inputs and you do not have any major outputs, so nothing's coming in, nothing's going out, that's a closed loop. So it's a closed system. We can also have systems in steady state, which means there's not a whole lot of change happening. So I like this bucket example that's in the book. If your input equals your output, so we're putting 1 liter per minute in and we're having 1 liter per minute coming out, the level in the bucket is going to stay the same. It's not going to go up or down because the amount coming in equals the amount going out. Same idea applies to environmental systems. Then we get into feedback loops. This is where environmental systems get a little bit messy. There's 2 main types of feedback loops. We have positive and negative. So I'm going to start with a positive feedback loop. Students very frequently get these 2 types of feedback loops mixed up. Now, a positive feedback loop, the way that I remember it is change leads to more change. So positive feedback loop, change leads to more change. So we have our population increasing, which means that there's more births. More births increase the population size. If you have more people, that means more people are having babies. So that means your population is going to increase, which means you're going to have more babies. And it's just going to keep looping. This change of births is leading to more births. So change leads to more change. That's positive. Negative, change leads to less change. So you're adding in something, which means you're going to be taking it away. Okay? Negative feedback loop. Change leads to less change. So if you have your lake level, and your lake level starts to drop, because maybe there's reduced surface area, now there's less evaporation, so lake level's getting a little smaller. So less water's evaporating, less water's going out into the atmosphere. That means your lake level can rise again. So it's starting to come back up. So you have a higher lake level, which means you have a bigger surface area. It means you have more evaporation, which means your lake level is going to drop. And when it drops, you're reducing the surface area, less evaporation, then your lake level will come back up. So change leads to less change. So it cancels each other out in a negative. In a positive, change leads to more change. That's a big concept from this module, is understanding how feedback loops work. And then we got some great practice review questions. Let me know what you're stuck on, and we will go over it more in class.